Okay, so I'm going to talk about ATSC 3.0. Since this is a work in progress, they made me put this chart up. I'm going to show you how things look today. It might change slightly as it moves to the final stages of standardization, but probably very close to what I'm going to show. For those not familiar, ATSC, Standards Development Organization, broadcast digital television, been around since 1983. Open due process, 120 members. Key thing now, there's a lot of international participation. It's not just US, there's people from Europe, people from Asia contributing technology into this. Elevator pitch, ATSC 1.0, digital television, first HD TV broadcast system. It's been around. Technologies are about 20 years old, 25 years old. Technology moves on, Moore's Law happens, a lot has happened. We thought it was time to create a next generation broadcast television system. The idea is to add value to the broadcasting services, give broadcasters more opportunities for new business, provide higher quality video, audio, UHD included, accessibility, personalization, interactivity. Broadcast had been sort of sticking to the tried and true Joe Six-Pack, lean back, get entertained. The rest of the world moved on. Broadcasting now is the opportunity to be like the rest of the world, be much more like the internet. In Target, we intend to have all standards complete, final stage, fully approved by the end of 2017. We're going into what's called candidate standard now. Standards are being approved and people are implementing and testing. Key features. 5, I think, key features of ATSC 3. Robust mobile reception. Still one of the big things about broadcast is getting information to things moving around. Ultra HD, another key feature. Immersive audio. I like to separate them rather than put them in the Ultra HD category. IP transport. I think it's really important for broadcast television and the future of broadcast television. And then advanced emergency alerting. Key feature, universally useful worldwide, different kinds of emergencies. Broadcast television is still the best mechanism to get information to lots of people in emergency situations. It's a layered system, like all of these are. I'm not going to go into all the details, but at the very bottom, system discovery. How can we evolve this? How can we change the physical transmission layer over time? Moving up through transmission, protocols, which is really what I'm going to talk about, presentation and applications. So, the old days, early DTV, ATSC 1.0, there was television, and then there was the internet that kind of evolved for entertainment after the digital TV transition was made. Really separate. TV was based on MPEG-2 transport, the internet's based on internet protocol. Broadcasting is a big thing, but it wasn't part of the internet. There's a lot of massive investment in the internet. It's being used more and more for entertainment. I think people who think of Dash are thinking about carriage over the internet. People recognize this. It's not a great place to be, a separate silo. So with ATSC 3, I'm stretching things a little bit, but you can think of broadcasting as becoming part of the internet. Based on IP, you can do a lot more things hybrid between pure broadcast and broadband delivery. By doing file delivery, segmented delivery like Dash, a whole bunch of possibilities that were never available to broadcasters and could mean a big commercial difference. Things like dynamic ad insertion become actually very, very easy to do instead of extremely difficult. Key things in the transport area, management and protocols. First off, we chose to drop MPEG-2 TS. ATSC 3 is totally based on IP transport. Second thing is no more streaming bits. Essentially now we've gone to delivering chunks of files using ISO-BMFF as the streaming delivery format. Third thing is instead of replicating an encoder or clock at the receiver, we're going to a universal UTC clock reference, a global clock that's used by all elements, no matter how they're delivered. These are three actually really significant changes in television broadcast, and they make the future possible by making these changes. Complicated protocol model. I'm not going to go into details. You will note that there are actually two, and this is hard, two transport mechanisms. The very left is based on MMT, MPEG-H. Middle for broadcast is IP, well, all on IP, but route dash. Far right is broadband. That is based on dash as well. You'll note that the middle vertical path and the right-hand broadband path are extremely similar. So what you can do in broadcast and what you can do in broadband are much the same and actually use the same tools. I think that's a large part of how this can evolve in the future. I put this on. I don't think anybody in the room needs to be explained what MPEG-dash is, but I highlighted a few words because I get a question a lot of dash is meant for a two-way environment, dynamic adaptive streaming. How can you do it in a one-way environment like broadcast? Well, it doesn't have to be adaptive. Dynamic, yeah. But it's a streaming model where a client requests segments that come across HTTP. The request doesn't have to go all the way back to a server at the origin. The request can go to, one example, a cache in the device which has an HTTP proxy. Things are broadcast into the cache. The client wants a segment. It asks over HTTP of a local cache, gets the segment. So the dash model works in a pure one-way broadcast environment. Works very, very well. Other changes. Dash is typically carried over flute. Flute's great. It's not the best. It's not tweaked the most for a unidirectional one-way system. There are a couple of twists you can make to it. It's backwards compatible. What you do over route will work exactly the same way over flute. It's just not optimized as much. Some features. It's a single transport protocol, carry linear TV, pushed files, signaling metadata. There's a mode that will allow early play out of segments. In the broadcast world where channel change time is critically important, you can get started before you have the entire segment in hand. And if segments are a second, 2 seconds, that's a little bit long for channel change. So early play out is a good thing. Extensions to the FTT, a number of other optimizations were made for the broadcast world in creating route. Synchronization. This is one of the key things, key changes in ATSC 3.0. The more conventional models where everything is broadcast over TS. The encoder clock is replicated in the decoder using the timestamps, PCRs, which control the flow of the SDC. With ATSC 3, where we have hybrid capabilities, you can put components in broadcast, you can put other components in broadband, you can have components come from different sources. They all need to be able to be mixed and tightly synchronized no matter where they came from. It's almost impossible to do that with local clocks. By going to a single universal global clock that everything is slave to, it all of a sudden becomes relatively easy to do. So ATSC 3 is based on UTC. UTC replicated and propagated out to the receiving devices instead of just replicating the encoder clock. Benefits. Broadcast isn't an independent silo anymore. We can start taking advantage of the evolution speed of the internet. Broadcast and broadband, pure delivery mechanisms. Being able to mix things. One example might be if you're broadcasting into an area with lots of diverse population that speaks many different languages. You may find that a couple of languages are very popular. You put them in broadcast. You may find there's some smaller populations that speak different languages. You can offer those over broadband. And the viewer can choose which audio language they want to hear to go with the video. And whether it's broadcast or broadband, everything is synchronized and delivered tightly. Business models. In the U.S., much of broadcast television is based on commercial revenue. The cable companies, with their distribution system, have been able to offer ad insertion regionalized to neighborhoods that allows them to multiply the income from commercials. In broadcast off a single big stick with MPEG-2 TS, the broadcasters have not been able to do this. By switching to essentially dash and IP transport, it becomes relatively easy to do ad insertion in the home, in the television, which is something that's sort of been a holy grail. And that really boosts the income possibilities for broadcasters. The revenues go up quite a bit. So, very, very short talk about the use of dash in broadcast television. But that's the direction ATSC 3 has gone. It's what we're building. It works. Dash is very, very useful. Thank you.